Okay, it is day 19, AMI day 20. If you are trying to make an extra letter grade on your third 9 weeks grade, you just have one more day of work to get done. Let's get right into today. We're doing 6.3 momentum. We went over some momentum yesterday, the laws of conservation of momentum. Today we're going to look at just the momentum equation. If you do not have the sheet printed off, get a piece of paper, put your name, your class, the AMI day, top right-hand corner. So for instance, Joe Smith, Physical Science, AMI Day 20. You'll need a writing utensil, of course, and then also, let me get this that way, and a calculator. You will need a calculator because there's multiplying and dividing of higher numbers and then some decimals. Your assignment is to read through the practice example, which you're going to do together, and then complete 1 through 11 evens. Evens. So you're actually only going to do 2, 4, 6, 8, 10, 5. And if you stay with me, I do one of them, so you're only doing 4. So let's get into it. My question for you today is, which is more difficult to stop if the two are going at the same speed, which is 35 meters per second, miles per second, I think is what this one is. Is it going to be a semi-truck or this nice little sports car? Which one is going to be more difficult to stop? Well, you're probably going to guess that it takes more force to stop the larger truck than it is the smaller truck, because we say that the truck has a greater momentum. And let's think back at where momentum comes from. Remember, Newton said that momentum is in his third law. We know that for every action, there's equal and opposite reaction, and that the total momentum in a system before and after collision is the same as long as the colliding objects are not influenced by an outside force, which could be friction. This also goes into play when we look at, I didn't mean to do that one, goes into play when we look at momentum, where P is momentum equals M times V. So let's answer the question. Which one is going to be harder to stop? Is it going to be the truck or is it going to be the car? So let's do a quick remember. P is momentum. M is the mass of the object. V is the velocity. Remember, velocity is speed plus the vector or the direction in which the object is moving. So question number 1, and this is going straight into your practice. So practice are the answer or the questions you're supposed to be answering on that piece of paper. It says if the truck has a mass of 4,000 kilograms, what is its momentum? Remember, first thing we always ask ourselves is, what are we looking for? Well, if I'm looking for something, that means there must be a question asked, and it says, what is its momentum? So we're looking for momentum, and momentum's abbreviation is done with the letter P. So we're going to use that equation, P equals M times V. When those two variables are together, it means to multiply. So what do I know? What is given to me? Well, the mass is given to me, which it says the truck has a mass of 4,000 kilograms. So I know I've got 4,000 kilograms for the mass in my truck. And I know the velocity, because remember, if we go back real quick, I'm going to go back to that page. It says that they're going the same speed, which speed is the same thing as velocity, but with the direction, of 35 meters per second. All right, so I know my velocity equals 35, and it said meters per second. Okay, so now what's the relationship? The relationship is that P equals M times V, and I think it even shows it next. P equals M times V. So now we're just going to plug in. We have found this is M, this is our mass, this is velocity, which is our V. We're looking for P, so we can say that P equals our mass, which is 4,000 kilograms, times our velocity, which is 35 meters per second. And if you look at our units are correct because you're going to multiply kilograms times meters per second. So it's 4,000 times 35, which you're going to get a big old massive number of 140,000 kilograms times meters per second. So that's how much momentum the truck has. So let's remember, the truck has a momentum of 140,000 kilograms times meters per second. So 140,000. That's how much force is going to have to be applied to make that to zero, to where it has no more momentum. So now let's look at the car and let's see how much momentum the car has. So if the car has a mass of 1,000 kilograms, what is its momentum? So we ask ourselves, what are we looking for? It says, what is its momentum? So we're looking for P. We're going to use that same equation, P equals M times V. What do I know? I know that I'm given the mass. It equals 1,000 kilograms, and they're going the same speed, which the speed is the velocity, 35 meters per second. The relationship they two have is P equals M times V. So we're now just going to plug in and solve for the momentum of the car. So I'm going to multiply 1,000 kilograms times 35 meters per second. If I multiply those together, I get 35,000 kilograms times meters per second. Okay, so now let's compare the two. So we said this one had a momentum of 140,000. Ooh, I did that backwards again. 140,000 kilograms times meters per second. And this one had a momentum of about 35,000 kilograms times meters per second. So which one's going to be more difficult to stop? If you said the truck, you are correct, because it has more momentum. So it's going to take more force to stop the truck than what it would do to stop the car. Pretty simple. So for the next 4 questions that you have, you're just going to use that equation where P equals mv, and that P represents mass, and P represents momentum, M represents mass, V represents velocity. Okay, so if you're one of my super smart kids and you know what velocity is, you notice that this vehicle is heading west, this vehicle is heading east, and if we were actually doing this the right way, this one would have a negative velocity and this one have a positive, but that's my fault. I messed up. This car should have been pointing the same direction and been on this side of the road. I couldn't find an image to match it, so we just went off of what the practice numbers were. Okay, so I've done 2 with you. You make sure that you do 2 on your paper, and now you do 4, 6, 8, and 10. And in all of them, you're using the equation P equals M times V. You even used it yesterday on yesterday's work. If you still don't understand it and you need help with the assignment, make sure you holler at me or you send me a message. Ask a friend. You're just plugging in. Remember, ask yourself, what am I looking to find? Am I looking for momentum? Am I looking for mass? Or am I looking for velocity? Oh, and real quick, before we do that, let me remind you, because you might be like, Miss Little, I need that triangle chart. So remember, it's a 3-point variable, or P equals MV, and anytime we've got it set up in multiplication, or the inverse proportion, P goes on top, M, V go on bottom. So if I'm looking for how to find mass on its own, remember, we would cover up the mass, and it tells us to find momentum divided by velocity. So that's where we say that M equals P over V. But what if we're looking to just solve for velocity? Get my triangle back out. P is on top, M and V are on bottom. I put my hand over the V, and it tells me P divided by M equals V. The velocity equals momentum all over mass. So if you need to write those down on your paper to remember where to input the numbers, then that should be a little bit of an extra help for you. And I hope that helps you. Always write that triangle at the top if you need that little extra bit of help. Okay, so reminders. 10 AMI assignments are due by May 1st. Please, this is to keep your third 9 weeks. We need those turned in as soon as possible. We have to get those graded. So please don't think, oh, May 1st, I'm going to go ahead and turn it in and I'll be good. Don't put yourself that close to the deadline. Get those turned in tests. We need to start grading those. That would help us out. Remember, we have over 100 students to grade, and if you're doing the extra 10 assignments on top, that's 20 assignments plus 100 students. That's 2,000 papers that we've got to filter through and grade. Do not, please, do not do that to us if you don't have to. If you need us to get the AMIs for you, holler at us, and we'll figure out whatever we can to help you out. Also, 10 additional AMI assignments are due by May 15th to raise by 1 letter grade. I don't know how to stress enough. I love you. I know you love me. Get those turned in. I need to grade them. Okay? All right. Hope you have a blessed weekend. It's Friday. I know it feels kind of weird that every day is probably like Friday or Saturday or Sunday. Hopefully you're keeping a schedule to help you keep things all kosher. So if you need me, holler at me. You know my number. Love you all. Have a good weekend. Bye.